All right. Algebra 2, this is for our 1 through 15 review. We'll cover the questions that you guys feel like you needed most, starting with 7, 8, and 9. Okay. Question number 7 says find a constant of variation of this data set. Well, the very first thing that I want to do is I want to determine what kind of variation is being used. So I'm looking at my x values. Do they go up or down? They're going up, so my x values are going up. My y values, are they going up or are they going down? They're going down. So what kind of variation would this be? Would this be direct variation or inverse variation? Inverse, right? So in an inverse variation, my equation is y equals k over x, correct? So if I want to manipulate the equation y equals k over x to find a constant to solve for k, how do I manipulate that equation to solve for k? What would I have to do to both sides to solve for k? Multiply by x. So xy equals a constant, correct? All right, so now I'm going to go through here, and I'm going to multiply all of those to find out what k is. Now, if k is the same thing for each of them, then k is a constant, okay? And I have a constant of variation. What's 6 times 8? What's 8 times 6? What's 10 times 4.8? What's 12 times 4? So what's the constant of variation? 48. Okay? Now, so that was an inverse variation, right? If they'd given me a direct variation, right? Because they could give me a direct variation question, right? In direct variation, y equals kx, right? And if I wanted to find the constant of direct variation, I would have to divide by x, correct? So the constant in that case is k equals y divided by x. So I'd have to go through here 8 divided by 6, 6 divided by 8, 4.8 divided by 10, 4 divided by... I would have to do that and see if there was a constant. Do we understand the difference between setting up direct and inverse variation to find my constants? Okay? So for finding constants, this is inverse, this is direct. Okay? I'm not guaranteeing you all I'm guaranteeing you is that there will be a direct or inverse variation question on the test, not what form it will take. So you need to be familiar with those equations and how to solve missing parts. Okay, question number 8. Can anybody tell me what this question involves? What is 66? Can anybody tell me what 66 is? The determinant of this matrix, right? How do I find a determinant of a matrix? Top left times bottom right minus. Okay. All right, so I can set up an equation, correct? What is the equation I would set up? Okay, negative 4 times negative 9. Missing something. Minus times. And what should this equal? 66. Okay? Now let's go back and let's solve. Let's simplify the left-hand side. Starting with what? Okay. Which is, okay, negative 4 times negative 9, which is positive 36. Okay? Let's go ahead and do, because we're not going to do subtraction yet, what's negative 6 times x plus 6? Okay, I got negative 6x or minus 36, right? But I'm subtracting all of this, right? Right? Okay, which means I need to do what? Distribute the negative. Good. 36 plus 6x plus 36 equals 66, right? Okay, what can I do with the left-hand side? Combine like terms. 36 and 36 is 72. All right, sorry. 72 plus 6x equals 66, correct? Okay. Now what? Minus 72. Okay, so I'm getting 6x equals what? Should be negative. What's 66? Okay, now what to find x? Divide by 6 on both sides. X equals negative 1. Okay? So, do we understand how to do that now? All right. What should I do before I hit submit? Check it. How am I going to check it? Plug in negative 1 up here. What's negative 1 plus 6? 5. Okay. So negative 4 times negative 9 was 36. Minus, what is negative 6 times 5? Negative 30. Okay. Is negative 36 minus negative 30 66? Right, because I'm going to add. Right, so I'm getting 66 equals 66. I ought to know how to check my work. Right, because these tests are getting more and more important as we get closer to the end of the quarter. Okay. All right, now we need what? 9? 7, 8, and 9 were our high ones. And RStudio charges $80 per class with a $60 membership. Each class costs just $60. After how many classes will the total be the same for members and non-members? The same tells me that they are equal. Okay, so I get an equal sign in here. So $80 per class, 80, or sure, you can do 80C, equals what on the other side? When, all right, with a $60 membership, so $60 membership plus $60 per class, 60C. Now I'm just solving for C, right? Because it wants to know after how many classes. Okay, so what do I need to do to solve for C? Axel. Minus 60C from both sides, right? Okay, what's 80C minus 60C? So I got 20C equals 60. Divide by 20 on both sides. C equals 3. After 3 classes, can I check this? Okay, what should I do to check it? Plug in 3 into both sides of the equation. What's 80 times 3? 240. All right, what's 60 times 3? Plus 60. So 240 equals 240. That's how I know I'm correct. All right, should I check my work tomorrow? Yes. Okay. Because I'm sure that you guys can get it right on the corrections, but it's not going to be worth near as much. That's 7, 8, and 9. Let's come over to 6. Okay. All right, look, we've got another variation question. Number of seconds varies directly as the number of minutes. Okay. So let's talk about setting up our equation. Let's use seconds. Let's use the variable s, and let's use m for minutes. How do I set up a direct variation?
Y equals k over x.
For direct variation?
Okay.
Kx. Y equals kx. Okay, direct means my x is in the numerator position. Inverse means x drops down to the denominator position. So what am I substituting in for y? No, variable-wise, what am I subbing in for y? S. Okay, the number of seconds varies directly as, well, actually, should be varies directly as the number of minutes. So minutes equals S times K, correct? All right. So when 180 seconds have passed, 3 minutes have passed, right? If 420 seconds have passed, how many minutes have passed? Well, all you're doing there is doing what?
Well, it'll be M equals 420.
All right. So M. Actually, I don't even know that that's. Make sure I've got this set up right. 420. All right. So the very first thing that we should have done is solve for my constant, right? Okay. So we need to go to this equation. If we have 3 minutes, 3 minutes equals 180 times k, correct? Okay. So what do I need to do to solve for k? Divide by 180. Okay. What's 3 divided by 180? That should give me a fraction. K equals what? 1 over 60? Okay, and that makes sense because a second is 1/60th of a minute, right? Yeah. So now that we have our constant, we can set the rest of it up, right? Minutes equals 420 times 1/60th. Now I can solve for my minutes. What's 420 times 1 over 60? 7. 7 minutes. Okay, we know how to set this up. Yes, you should be able to know that if I take 420 seconds divided by 60, that's going to give me my minutes, right? And if you show me that work, I'll probably still accept it because you're using some common sense there. Okay, I'm not going to dock you for using common sense. Okay, the next question up is 16. You're good, okay. 16. Okay, a subway pass. This is a lot like that other question we see. So we're starting to see some commonalities in questions that we're having a hard time understanding. All right, a subway pass costs $20 and $1.50 is deducted from the balance on the pass every time you use it. Okay, write and graph an equation to represent this situation. And then it says graph it again. Okay. So I'm more concerned, a little less that you're graphing it and more that you're able to write it. So it costs $20, $1.50 is deducted from the balance every time you use it. Okay? So we should start with what? Probably our $20, right? Okay? And then what? Deduction means what? Subtraction. What am I subtracting? $1.50 every time I use it. So $1.50 per time. So $1.50x. So y equals this. Now, if I want to write this into a slope-intercept form of an equation, how might I want to rewrite this? And then could you graph that? All right, you're going to find, I'm going to go up 20 on the y-axis, and I'm going to drop, you know, we could write that, I mean, 1.5 is down 3 over 2, right? Negative 3/2. So, and then could I graph that? Yes? Okay, so we won't necessarily do that in front of you today, but you should know how to graph that. Okay. All right, that's 16. Next is what, 17? 17. Let's come down here. Classify this by degree and number of terms. Degree refers to what in this right here? What is the degree? The exponent. All right, and the degree tells me that this is what type of equation? Isn't it quadratic? Yeah. Okay. How many terms does it have? One. So because it only has one term, it's mono, right? So let's look down at 17's answer. Okay, just so I'm not leading you astray. Quadratic and monomial, right? A quadratic monomial. I need that thing to go away. Quadratic by the degree, monomial by the terms. All right, so if I'm going to tell you to look at something, all right, 17, and you guys can do this yourself because you guys have the answer key, right? All right, do you notice here with 17 that it gives you a lesson to go back and look at? Right, and if you look at lesson 11, both in your notes that I sent you and in your book, you should see a chart that's going to outline what it's called by its terms and what it's called by its degrees. You need to study that because it probably won't look like that question, right? It could take it to the fourth, it could take it to the fifth, right? They could do all kinds of different things. So don't assume it's going to be quadratic monomial, right? It could be quintic, right? It could be all kinds of, it could be a trinomial. Do you understand? So study those out so that you know beyond a shadow of a doubt, hey, I'm going to be able to get this, okay, no matter what they throw at me. All right, 17, let's go back up to question number 4. What is the new amount when 36 is increased by 60%? So our process here is to take 36 and do what with it? Well, we have to know what 60% is, right? It's 60% of what? 60% of 36, right? It's not just 60% of whatever, it's 60% of 36. So of in math means multiply. So we're going to take 36, or we could rewrite it so that I'm saying it right. 60% of 36 is equal. So what is 60% of 36? 21.6. All right, now the 21.6 couldn't possibly be my answer because we're increasing 36 by that, right? So, I mean, if I went to the store and they said, you know, it's been marked up 60%, and I see that the new price is actually lower than the original price, that couldn't be an increase. So what do I actually have to do with 21.6? Add 36 to it. $57.60, right? Or if, I guess they didn't actually say it was dollars, but let's say it's dollars. 57.6 or $57.60 if it is a word problem. Okay? Does that make sense? We got that now? Make sure that you add 2. Now, could that be reduced by? Right? Could they have changed the question to say, what is the new amount when 36 is reduced by 60%? That means minus the $21.60 from 36. Does that make sense? So it's still not just $21.60. I have to take 36 minus 21.6. So be aware of that possibility that it could be very similar but opposite of that. Okay, what was that? That was number 4. We need number 10. Okay, create 2 matrices A and B, one for tickets sold at theater A and one for tickets sold at theater B, then add A and B. Okay, so what you're doing here is you're going to make a 3x3 matrix here and a 3x3 matrix here. What am I going to get whenever I add a 3x3 and a 3x3? I'm going to get a 3x3. Now, I am not multiplying these matrices, correct? No, I'm adding. So it's 43 plus what? Plus 15. So I should be getting 58, right? Okay, 29 plus 27. Right, 29 plus 27 is 56. All right, do we see the pattern here? Okay, do I need to work the rest of this out? No, you guys know how to add. What if they ask me to multiply? All right, yeah, I would multiply, but it would be more complicated, right? It's more complicated than just multiply the numbers. Okay? They could very easily ask me to do that, in which case, right, if it was a 3 by 3 times a 3 by 3, right, I'm still getting a 3 by 3, but it would be first row, first column. So 43 times 15 plus 43, yeah, first row, 43 times 15 plus 29 times 63 plus 39 times 25 to get that first row, first column, right? So it would involve quite a bit of math just to get one element. But we are aware of how to do it. Okay, good. All right, that was what, number 10? Number 10, so we need what, number 12? Number 12. It's up here. Hannah lives 4 miles from school. We've seen this question before, right? Hannah lives 4 miles from school. Ellen lives 7 miles from school. We want an inequality to represent the possible distances between their homes. So it's a range of values. Just to kind of shorten this up, we would look at 4 plus 7, or really let's do it this way: 7 plus 4 and 7 minus 4. You'll take the greatest number, you'll add and subtract the smaller number. So I should get 11 and 3. What we are going to get is going to be equal to, but in between 11 and 3. Why? Because if here's the school and one of them lives 4 miles, the other lives 7 miles, in terms of their distance from each other, that's 3. But it's possible that she could have lived 7 miles in the opposite direction. That's 7 plus 4. They could live at most 11 miles apart. They could live at least 3 miles apart. Does that make sense? Okay, good. All right, that was 12. We're moving on to 15. 15, solve and graph the compound inequality. All right, we got 6x minus 1 is less than 11. Let's solve that. What do I want to do first? Add 1 to both sides. All right, I got 6x is less than 12. Divide by 6. X is less than 2. All right, let's do the other one. We've got 6x plus 4 is greater than 46. Now what? Minus 4. 6x is greater than 42. Divide by 6. X is, no, not equal to, greater than. Okay? So we've got x is less than 2. Or, yeah, x is less than 2. X is greater than 7. So on a number line, if this is 0, right, we've got 7 over here. We've got 2 right here. Okay? Are these open or closed circles? Open here, open here. This one from 2, is the arrow going to go to the left or to the right? Look at it. Everything that you own? Oh, okay. I said everything that you own, because you said to the left, to the left. No. Okay. Now this one here at 7, am I going to the left or to the right? Okay. Right. It is a disjunction. Does that make sense? So now we not only know how to solve it, but we also know how to graph it. Okay. All of that's important. All right, last question, which is number 20. Does anybody still need what I've got on the board here? No, we're good? All right, number 20, use Cramer's rule to solve. Okay, there are other ways to do this, but let's go ahead and use Cramer's rule to solve this. Cramer's rule, we'll say x equals, okay, let's start off with this. What numbers are going, if we're doing x equals, top left determinant. Okay, what goes in there?
6 and 2.
We're looking at number 20, right? 11 and negative 11, just like that, correct? Okay, what goes on the right-hand side?
7 and 4.
Negative 7 and 4, correct? Okay, what about in the bottom?
6 and negative 5 and negative 7 and 4.
Good job, you guys are rocking that. Okay, Determinant. So I've got 11 times.
4.
So let's go ahead and write that as 44 minus what?
Negative 77.
Are you
Positive 77.
Okay, 44 minus 77. Good, because negative times negative is positive. Let's go ahead and get our bottom. What's 6 times 4?
24
Okay,
plus 35.
plus 35. Okay, you'd go ahead and reduce. That'd give you your x value. Whenever we go to do our y's, can we keep our denominator the same? Yes, but what's going to change is in the numerator position, we're going to put 11 and negative 11 on the right. We're going to go ahead and put 6 and negative 5 back on the left, and then solve. Okay, hopefully that gets you guys enough. You guys should be able to find the answer for 19 in the answer key. Study for your test. We'll see you tomorrow.